Have you ever scrolled through your feed and witnessed a phenomenon unfold in real time? One moment, your digital world is calm, a predictable stream of updates from friends and familiar creators. The next, it seems every single person is talking about the same thing: a specific dance, a strange new meme, a political hashtag, a bizarre challenge suddenly dominates the entire platform. You might have seen two nearly identical posts from two different creators, launched on the same day. One vanishes without a trace. The other detonates, achieving a kind of cultural escape velocity. This isn't random luck. It's not just about the quality of the content. It's about the hidden architecture of the networks we live in. What separates the forgotten post from the viral sensation? The answer lies not in a single, simple cause, but in a precise, three-part mechanism. It begins with the very wiring of our social networks, which are built like an explosive device waiting for a spark. It then depends on the psychology of social influence, where our decisions are triggered by the actions of those around us. Finally, it involves the chaotic, cascading nature of collective attention itself, a force that can be channeled and directed, but never fully controlled. First, we will examine the network structure, looking at how a combination of ultra-connected hubs and tightly knit local communities creates the perfect conditions for a rapid-fire spread. Then, we will dive into the science of contagion, revealing why a single exposure to an idea is often useless, but seeing it from 3 or 4 different friends can flip a switch in our brains. This is the world of complex contagion and social proof. It explains why a trend can smolder for days and then suddenly ignite everywhere at once. Finally, we will look at what happens when these thresholds are crossed on a massive scale, creating what scientists call an attention cascade. We will see how information, both true and false, rips through the social fabric at incredible speeds. Understanding this system is about more than just satisfying curiosity. It explains the mechanics of political mobilization, the rapid spread of misinformation, the dynamics of financial markets, and the very nature of how ideas now compete and evolve. This is the invisible physics that governs our digital lives. The digital worlds we inhabit are not built like orderly city grids. They are messy, unbalanced, and fundamentally unequal. This structure is the first key to understanding why trends can explode. Scientists call these networks scale-free, which is a technical way of saying that connections are not distributed evenly. Imagine a social platform where every user had roughly the same number of friends. That would be a regular network. But social media is the exact opposite. Most users have a modest number of connections. A tiny fraction of users, however, have an astronomical number of connections. These are the hubs, the celebrities, the major news outlets, the mega influencers. This phenomenon follows a power law distribution. Plot users versus connections on a log-log graph, and a straight line appears. This line reveals a stark reality. For every user with millions of followers, there are millions with just a handful. This isn't a bug. It's how these networks grow. We are drawn to what is already popular. New users tend to follow accounts that are already famous. That creates a feedback loop. The popular get more popular. The power law exponent, the slope of that line, often settles near -2. That matches observations on Twitter and on Instagram. Most users are nearly invisible. A few have megaphones, and that imbalance is the launchpad for viral trends. On a scale-free network, a message can leap across vast social distances in an instant. A single post from a major influencer can simultaneously reach millions of people who are otherwise completely disconnected. If we zoom in from the bird's eye view, we see another crucial structure: dense local clusters. Our social lives are not random. We are tightly connected to groups of people we share something in common with. Our family, our co-workers, our friends from school, fellow members of a niche online fandom. This creates dense pockets of connectivity. This clustering is a hallmark of what scientists call small world networks, a mix of dense local clusters and a few random long-range connections that act as shortcuts. These clustered neighborhoods are the perfect incubators for new trends. Within a tight group of friends, an idea can quickly reach a point of local saturation. Trends don't spread across a flat grid. They detonate inside dense pockets, then leap through hubs and bridges. Think of it like a fire spreading. Dense clusters are like patches of dry forest. Hubs are like strong winds carrying embers miles away. The combination creates an uncontrollable wildfire. The network supports local intensity and global reach, setting the stage for sudden flips in attention that define virality. The wiring is loaded. The next question is, what pulls the trigger? Now that we understand the explosive wiring, we must turn to the trigger. What actually makes an individual decide to adopt a new trend? For a long time, scientists thought of it like a biological virus. This model is known as simple contagion. It suggests the more you're exposed, the more likely you are to adopt. However, this analogy is fundamentally flawed. Adopting a new behavior is not like catching a virus. It often involves a cost, a risk, a social calculation. The crucial difference lies in the source. In reality, the identity of the messenger often matters more than the message. This is complex contagion. It's not about how many times you see a trend. It's about how many different, independent friends you see endorsing it. This was tested in a PLOS1 study on Twitter hashtags. The complex contagion model fit the data significantly better. People were waiting for social confirmation. This is about overcoming an activation threshold. 1 friend might be an anomaly. 2 is a coincidence. 3 is a trend. New work gives causal proof. A 2025 sociological field experiment used a peer encouragement design. Those with 2 encouraged friends were significantly more likely to redeem the coupon and share it themselves. Higher-order models show that group interactions, like group chats, can trigger adoption that no pairwise influence could create, meaning a trend can need the group vibe to ignite. Once thousands of thresholds are crossed, the phenomenon enters the attention cascade. It's the digital equivalent of a nuclear fission. Each adoption triggers several more. Virality isn't just lots of shares. Structural virality captures whether spread came from one giant influencer or many small chains of ordinary users. Some trends are born in the spotlight. Others climb from the basement floor through thousands of tiny handoffs. A famous Twitter study of 126,000 rumor cascades found false news spread significantly farther, faster, and deeper than true news. Partly because novelty and emotion drive attention cascades. A lot of virality is brokered. Prominent users create new network ties by amplifying content from less visible creators. Influencers aren't just loud, they literally redraw the network around you. But does a massive spike translate into long-term growth? A 2024 analysis found that many viral spikes produce only transient engagement, suggesting that going viral is usually a temporary shock, not a permanent upgrade. It's a flash flood, not a change in the course of the river. This 3-part engine, explosive wiring, a social trigger, and a cascading release of attention, provides a complete framework. The network structure loads the gun. Complex contagion pulls the trigger. Attention cascades decide how loud the shot rings. Understanding this provides new rules. For creators, foster genuine engagement. For platforms, disrupt harmful consensus. For all of us, it's a form of literacy, giving us agency to become more conscious consumers and creators of culture, with a clearer view of the invisible architecture that connects us all. Subscribe if you have not as yet. This content is rare.